Okay, hello everyone. Let's go ahead and take a look at 3x3 and larger matrices. Okay, now let's go ahead and just continue with what we did before with 2x2 matrices. And notice that we said that if A is going to be A, B, C, D, then the determinant of A, which can be written like this and like this, is going to be the same thing as AD minus CB. Now, what did we need the determinant for? Well, we used the determinant to find A inverse. And A inverse, of course, was 1 over the determinant of A times by this matrix here. And of course, what did we need A inverse for? We needed A inverse so that we could actually solve a matrix equation, okay, and solve a system of linear equations. Now, what we're going to do in the next section is that we're going to take a look at 3x3 and larger matrices. And what we're going to do is we're going to find both the A inverse as well as the determinant of a 3x3 matrix. So let's go ahead and take a look. First of all, if we have a 3x3 matrix, let's call this again A. If we wanted to find A inverse, now A inverse is a much more complicated process being that this is a 3x3 matrix. For the standard level course, all you're going to have to know how to do is use your graphing calculator to find out what A inverse is. Okay, and we know how to do that using, for the two-dimensional matrix, it's the same thing for the 3x3 matrix. So what we want to do though, is you also need to be able to find the determinant of a 3x3 matrix by hand. Now if we do that, what we do is we call the whole process a decomposition of the 3x3 determinant to 2x2 determinants. Okay, and this is how you do it. If we go ahead and take a look, let's just say for example, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice that we have the straight bars here, not the brackets, right? Straight bars, which means that we're actually looking for the determinant of this particular matrix. Okay, so if I was to go ahead and decompose that, this is the way that you do it. We go ahead and take a look at the top row of numbers here, 1, 2, and 3. And notice that's where the numbers are here, 1, 2, and 3. Now notice also that this is a positive, that's a negative, and that's a positive. Okay, and that pattern is always going to be a set pattern in order to evaluate the 3x3 determinant. Now, how do we go ahead and determine what the 2x2 determinant is for each one of these here? Now, if we go ahead and just hide, say for example, the row and column that number 1 is in, the first, this, so you should be able to see now where that 2x2 determinant values are coming from. If I do the same thing with the 2, again, you should be able to see where that 2x2 determinant values are coming from. And if I do it for the 3, those are the values there. Okay? So what happens then is that from here, this determinant is actually decomposed to this here, which is composed of 2x2 determinants, and of course, we know how to go ahead and evaluate a 2x2 determinant. So we just go ahead and say 45 minus 48 minus 2 times by 36 minus 42 plus 3 times 32 minus 35. We do all the math and we come up with 6. So what do we know about this then? We know again that for that particular determinant, the value is 6. For that particular matrix, it is a non-singular matrix. Okay? And there you go. That's all that we have to do. We're just taking a look at larger matrices, and 3x3 in particular, and being able to calculate with your graphing display calculator A inverse, and also by hand the 3x3 determinant. So give it your best shot. Let's see how you do, and good luck. Okay? Bye.